Video, we are looking at the last conic section, which is a hyperbola. Now, the definition of a hyperbola, it is the set of all points in a plane. So if I were to plot all these points and create this curve, it is the set of all those points on that side and on this side, such that if I take the distance from one of these points to the foci, so we go from here to here, we call that D1, and I can go to the other focus, and we'll call that D2. So if I take the difference of those, I do, let's say D1 minus D2, that number is going to be the same no matter what point I pick on that hyperbola. So if this is D3, and we'll call this D4 to that one, they're going to be equal to each other. That's what that's telling you for the definition of a hyperbola. Now, the parts of a hyperbola are very similar to the parts of an ellipse, except we don't really have co-vertices. So we have a center, which is just like it was before. So we have our center. We'll put it right here. That's for a horizontal hyperbola, and for a vertical hyperbola, we have one right here. We have vertices on it, and so the vertices would be right here. Here's one vertex, and here's the other vertex. And then same thing for a vertical, we have one right here. This is a vertex, and this is the other vertex. We have foci. Now, the foci are inside the curved part of the hyperbola. So here is one focus, and here is the other focus. So a hyperbola opens up towards the foci. So here's one focus here for a vertical, and here's the other focus. And we have the asymptotes. Now, asymptotes are to be graphed with dashed lines on it. On this case, I have them as solid lines so we can kind of see them a little bit more clearly. So you have an asymptote here, and you have one here. And the same thing on the vertical. You have an asymptote here, and you have one here. Now, the asymptotes, so you can understand, those are defined by slope and center. You see how the intersection of the asymptotes are the center of the hyperbola. And we'll look at some more patterns like we did before. There's a video that even goes over the patterns for the formulas on these, but this is the general structure on it. Now, when you are graphing, a little advice is when you are graphing a hyperbola, make sure that you curve towards the asymptotes. The further away from the vertex you go, the closer that curve becomes to a straight line. It approaches that asymptote. It's not a U shape. It goes towards the asymptotes on it, on both sides. So our formulas. Now, unlike what I did for ellipses, I'm actually going to start with the equations on this one. So a horizontal hyperbola, which is defined by the transverse axes. So transverse axis would be horizontal. If it's opening horizontally, it'd be vertical if it's opening vertically. If I start with the equations, notice that your x minus h squared starts off for horizontal, but the y minus k squared starts off with the vertical. So that's the first part. You do need to start with the actual structure of the equation for hyperbolas. Everything else, for the most part, really stays the same. The x minus h and the y minus k can trade spots. A squared, unlike ellipses, a squared is always under the first fraction. So we know from before that our center is the coordinate hk. That's still true, and you still want to start there when you are graphing because everything deals with that hk. I mean, look at this. Here's the k and here's the h. Here's the h to k for the center. Look at that. This has hk. This has hk. So everything is dealing with going from the center in some way, some distance. So we're going to start with the center. Now, if we go to, we'll come back to the asymptotes. If we go to the vertices, again, notice the vertices have this plus or minus a in it. And if it's horizontal, you're moving a units to the left and you're moving a units to the right to get the vertex. If it's vertical, you're adding, subtracting a to your k value. So you're going up and down k units. A is still defined as the same thing. It is defined as the distance from the center to the vertex. That is the same definition that we had for ellipses. And I can even look at it in this case too. Your foci are created by adding, subtracting c on it. And again, horizontally, you're adding or subtracting c left or right, so that affects your h. Vertically, you're adding, subtracting c up and down, so that affects your k. But it's the same definition as ellipses. C is the distance from the center to a focus. So that's good news. And one thing to also know is if it's horizontal, you go left, right. If it's vertical, you go up, down. So both of these are on the transverse axes. So the vertices are on the transverse axes and the foci are on the transverse axes. So I've covered the vertices, I covered the foci. I haven't covered the asymptotes. So that's a little trickier. So if we take a look at the asymptotes on it, we want to figure out and the slope of the asymptotes. And I just say we need to figure out the slope because look at the structure. They both have the y minus k, the x minus h in them. So, and that's given to you in the original problem. Really what we want to focus on is what's the difference by slopes? Well, one's b over a, plus or minus b over a, one's plus or minus a over b. So how is that helpful? So I have plus or minus a over b, and I have plus or minus b over a. Well, most basic definition of slope is rise over run. So in this case, my rise is on top with my a value. So I'm going to rise to the vertex. So that's why right here, when you are going a units from the center to the vertex, you're going up or down. That's a rise. So that's why it's plus or minus a on top. But in this case, the distance from the center to a vertex is on the bottom. So you are running left to right to create that part. So that's why this on the bottom is it's attached to the x here. So it's a run. Attached to a y here, so it's a rise on it. So there's your basic formula breakdown. If you need more in-depth understanding the patterns, watch the video for the formula helps. Now for the c value, something that's a little bit different, let me move this out of the way, is your c squared equals a squared plus b squared now. Very similar to the Pythagorean theorem on how we're going to find it. You have the formula sheets, I would print them out, and I would look them as we go through. So if I start with example number 1, again, it's organized by concepts that are on your quiz. Concept 1 is identifying all parts of hyperbola and graphing. The first thing you're going to want to do is you're going to want to look at which equation you're looking at. And so I have the y plus 2 squared first. Now that's telling me I am dealing with a vertical hyperbola. And that's because the y minus k squared appeared first. And that's going to be useful because it's going to tell me which formulas to look at. It's going to tell me what my values are on it. And so right away I can see, remember, it's y minus k. So this is k equals -2. That is the k value for the center. This is h equals 3. So again, I'm going to find it. My center, be very careful. It's h comma k, so it's 3 comma -2. I'm going to find it, and I'm going to plot it. And I am going to put a c for the center. Then if we look at the formulas for it, we're dealing with a vertical, so let's get rid of all of this. If I'm dealing with a vertical on it, my a squared is the first denominator. So in this case, a squared is 16. So a is 4. The distance from the center to the vertex is 4 units up and down. So I'm going to go from my center up, 1, 2, 3, 4, plot the point, and I'm going to put a V. From the center down 4, 1, 2, 3, 4, boom, put a V. Wait, I counted. I actually did not use the formula. I apologize. Let's use the formula. The formula on the formula sheet for vertices for a vertical hyperbola says h comma k plus or minus a. So that would be 3 comma negative 2 plus or minus 4. So let's see, those coordinates would be 3 comma negative 6, and those would be 3 comma 2. So there I use the formula if it makes you happy, but notice I got those same points here and here by counting a units from the center and the direction it tells me to count. B squared is 36, so B is 6. Now we're going to use that to get the foci, to get the asymptotes. So hold on 1 minute for that. Let's focus on the foci. And so C squared equals A squared plus B squared. So C squared equals 52, so C is the square root of 52. Now if I simplify that radical, a 4 goes in there, so that would give me 2 square root of 13, which is approximately 7.2. Now the formula for the focus on it, if you look at the formulas above, is h comma k plus or minus c. So I'm going to do 3 comma negative 2 plus or minus 2 square root of 13, which is plus or minus 7.2. So if I want to use the formula, I can use the formula here. But if I want to count, I can count because c is the distance from the center to the focus on the transverse axis, which in this case is vertical. So 1, 2, 3, 4, 5, 6, 7.2. And then 1, 2, 3, 4, 5, 6, 7.2. So there's a focus and there's a focus. Done. If I look at those coordinates, they would be 3, negative 9.2, and would be 3, 5.2. And again, you could just add and subtract 2 radical 13 from negative 2 and get the same answer. So now it's the asymptotes. It's time for that. The asymptotes in this case, we have the formulas. It's y minus k equals something, x minus h. We just need to know which one. And you know what? It shows us. We can just go right there and see it's going to be plus or minus a over b. But notice y minus k is given to us in the equation. We have y plus 2. We have x minus 3. So I know it's going to be y plus 2 equals plus or minus, and I have x minus 3. Now you could use the formula and you can see slope is going to be plus or minus a over b if you look at the formula sheet, which is, it's helpful, but that also means, remember, a is on top. And so you're rising from the center to the vertex. I mean, that should make sense. So my a value, if I scroll out, was 4. My b value was a 6. So always simplify your fractions, so that's 2/3. So there is the asymptote. So what we do is we go from the center. And that's why on the front page I said your asymptotes are defined by the slope and the center. So from the center, go up to right 3. Go up to right 3, and I can go down to left 3. Down to left 3, and there's your slopes for the positive asymptote. No, I'm going to go down to right 3, down to right 3 from the center, and up to left 3, up to left 3 from the center, and just keep going. And that is going to be the negative asymptotes. And I'm going to graph those with dashed lines. And when I go to graph, I am going to just start the vertex, and I'm going to stretch out to the asymptotes. So from the vertex, I'm going to stretch out to the asymptotes. It's not U-shaped. The further you go out, the closer it's going to get to those asymptotes. The further you go out, the closer it's going to get to the asymptotes. I guess I didn't answer transverse axes. I've said it before. This is a vertical hyperbola. That's the first thing I addressed right away. So I should have written that down in that box right at the beginning. But that's a vertical hyperbola. If you want to make a note of a trick, the trick is way you see it in the equation, it's K, then H. So verticals, you gotta kind of label the K, label the H, and then do the center. Don't try and just go left to right order. So in this problem right here, the second one, I see my x minus h squared is first, so this is a horizontal hyperbola. So I'm going to not make the same mistake again. I'm going to go down to where it says transverse axis here, and I'm going to write down horizontal, so I can knock that one out right away. And so when it's a horizontal hyperbola, I'm going to always start with finding my center no matter what. So in this case, h is attached to your x, so this is -1, and this is 2. So my center is h comma k, so that's -1 comma 2. That's my center. The formulas all on this page for them. My a squared is always under the first fraction. It's the denominator of the first fraction. So my a squared in this case is 25. And I'll just go ahead and write down that b squared is 49. So I have a is 5. Now, how does that help me? That tells me the distance from the center, which I did not plot, -1, 2. The distance from the center, even the color coding, to the vertex, which is, I'm telling you, horizontal, is 5 units. So I'm going to count 1, 2, 3, 4, 5. Boom, there's a vertex. Going to go to the left. 1, 2, 3, 4, 5. Boom, there's a vertex. Wait a minute, I did not use the formula. I apologize. The formula says it's h plus or minus a comma k. So let's just plug in our numbers. That's -1 plus or minus 5 comma 2. So let's hope I'm right. I have -6 comma 2. That looks like it's this point right here. Good job. Then I have 4 comma 2. And that looks like it's that point right there. So look at that. Use the formulas, or I can count using the definition of A. B squared is 49, so B is 7. In this case, for hyperbolas, c squared equals a squared plus b squared. So c squared equals 74, so c is the square root of 74. So for my focus, the formula for horizontal is h plus or minus c comma k on the formula sheet. So I'm going to have -1 plus or minus the square root of 74 comma k. Now the square root of 74 is approximately 8.6. Now I'm going to use the counting, but I could also use my formula. I could take -1 plus 8.6 comma 2 and -1 minus 8.6 comma 2, and I can get the same coordinates. I prefer to count. 1, 2, 3, 4, 5, 6, 7, 8.6. There's a focus. Now let's go to the left. 1, 2, 3, 4, 5, 6, 7, 8.6. There's the other focus. And I'm going to get the same coordinates no matter what. If I use the formula, if I count, I'm going to get -9.6 comma 2, and I'm going to get 7.6 comma 2. That's it. So the last part is my asymptotes. Again, that's on your formula sheet for it. I mean, it's right here, horizontal hyperbola that we're dealing with. Boom, there is your asymptotes equation. You have it. You are told the slope of the asymptotes is going to be plus or minus b over a. I like to understand why. Remember, a was underneath the x. It's dealing with a left to right movement. So your a is a run on it. Your b is the rise. So the slopes of the asymptotes is going to be plus or minus b over a, so plus or minus 7/5. The way you write the equations of the asymptotes, you use the parentheses, the objects in the beginning of the equation. It is y minus k, so y minus 2 equals plus or minus my slope, so plus or minus 7/5, and then x minus h, which is given to us as x plus 1. So we're keeping the same parentheses that we're using up above. It's just our job to figure out the slope. So from the center, I'm going to go up 7 and to the right 5. 1, 2, 3, 4, 5. That's a big slope. I'm going to go down 2, 4, 6, 7, and to the left 5. That's my negative slope asymptote. And I'm going to do the same thing. I'm going to go down 7 and to the right 5. And I'm going to go up 7 and to the left 5. That's my negative asymptote. And then I sketch my curve. Again, you're going to curve out towards the asymptotes. It's going to still be a little curved, but slowly get closer and closer to the asymptotes as you sketch. And there is a horizontal hyperbola for it. So let's look at the third example. Remember, the first concept is being able to identify all parts of a hyperbola and graphing. So this is what we're doing first. Again, I take a look right away. This looks like it's horizontal. So I go to transverse axes on it. My transverse axis is horizontal. If I were to look at the formula sheet, it says x minus h. So my h is -4. Y minus k. So my k is 5. So I have my center. I am going to plot the coordinate -4, 5. So -4, 5 right here. That's my center. The formula sheet shows you a squared is always the denominator of the first fraction. So I am going to write down right away that a squared is 81 and b squared is 144. So then a is 9. Now again, I can use h plus or minus a comma k. I can use that formula, -4 plus or minus 9 comma 5, and I can get my coordinates of the vertices. You could just do that. I know it's a horizontal hyperbola, and I know a is the distance from the center to the vertices, so I'm going to count right. 1, 2, 3, 4, 5, 6, 7, 8, 9, and there's a vertex. Go to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, and there's the other vertex. Or I can use this up here and plug them in. Now, what that's going to give me, it's going to give me the coordinate -13, 5 on the left side, and it's going to give me the coordinate 5, 5 on the right side. The focus on it is using our a squared or b squared. I'm just going to go ahead and write down b equals 12. I'm going to save that for the asymptotes. But c squared is a squared plus b squared. So in this case, I get 225. So c is the square root of 225, which is perfectly 15. So the distance from the center, hk, to the focus on the transverse axis, which is horizontal, C units left and right is your focus. That's the formula on the formula sheet. And I could plug it in, -4 plus or minus 15 comma k. Done. You can, well, sorry, I should probably plug in k. In this case, k is 5. I can use that and just do the math, -4 plus 15, and then -4 minus 15, and I'm done. I prefer to count. So I'm going to go to the left 15 units, which puts me over here. There's the focus. And I'm going to go to the right 15 units, which is going to put me over here. So there's the other focus. And those would be the coordinates -19, 5, -4 minus 15, and then it'd be 11, 5, -4 plus 15. Same idea, I just counted. Now when I'm doing the asymptotes, I know it's going to keep the same parentheses, so it's going to be a y minus 5, and it's going to be an x plus 4. My job is to figure out what's my slope. Now, in this case, A is under the X. So if I'm thinking rise and run, my A is a run. It's a left to right movement. So my slope is plus or minus B over A. And I can even look at the formula sheet and see that as well. So I have plus or minus 12 over 9, which in this case simplifies into 3 goes in there 4 times, 3 goes in there 3 times. So that's plus or minus 4/3. So from the center, I'm going to go up 1, 2, 3, 4 to the right 3. And I'm going to keep going 1, 2, 3, 4 to the right 3. 1, 2, 3, 4 to the right 3. And I can do the same thing. I can go down 4, 1, 2, 3, 4, left 3, 1, 2, 3, 4, and so on. And I'm going to repeat this 1, 2, 3, 4, and boom. And so there is my positive asymptote. And I can go down 4, 1, 2, 3, 4, and so on. So you can keep graphing the asymptotes. And then the same thing here. So 1, 2, 3, 4. It's a big graph. And there's the negative asymptote finally. And when we graph it, we're going to curve out towards the asymptotes. We're going to curve out to these asymptotes. We're going to curve out and approach the asymptote. We're going to curve out and approach the asymptote. There's how you graph a hyperbola for it. That's concept one. Identify all the parts and graph. Now be careful, like we said, a squared for hyperbola is different. It's always the denominator of the first fraction, but look at the formulas to help you. Please watch the other video. Now concept two is completing the square. This one has a tricky part. If you want to kind of know what problems you want to practice, it's this one. There's one reason why. We're going to do the same idea. We're going to group them together. So I have the 4x squared, and I have the negative 16x, and I'm going to group together my y's, which is a negative 5y squared and negative 40y. So let's just kind of group those together first. So I have 4x squared minus 16x minus 5y squared minus 40y. The 164 is already on the other side, which is very helpful. Remember, we can only do the square x squared. I'm going to factor out that 4, so that gives me a minus 4x. And I'm going to insert my placeholder for when I do complete the square for that one on it. But here's the part that's tricky on it. When you're completing the square here, this leading coefficient is negative. It's a negative 5, so I have to factor out a negative 5 from it, which is going to change this to a positive y squared. But you have to be careful because that's negative 40y into a positive 8y because you factor out the negative on it. And then I'm going to insert my placeholder, and I have equals 164. I have to insert my placeholders on the other side to keep the equation balanced for it. And so now I'm going to complete the square. So I'm going to take half of this term, which is negative 2, and I'm going to square that number, and that's a positive 4. But remember, I'm really adding 16 to the other side. And I'm going to take half of this number, which is a positive 4. I'm going to square it, and I'm going to get plus 16 in that case. But I'm not really adding 16. Again, be cautious because you factored out a negative 5. So you're really multiplying that, and you are really subtracting 80 in this case. So I have 4 parentheses x, looks like it's going to be minus 2 squared, minus that 5, and that'd be a y plus 4 squared. And that equals 164 plus 16 minus 80, which is 100 perfectly. But again, the standard form equation, let me just zoom out, look at it. The standard form equation for a hyperbola is equal to 1, just like it was for an ellipse. So we're going to do the same thing that we did for an ellipse here, is we are going to create that 1 on the right-hand side by dividing. But I have to divide each term on the left-hand side by 100 as well. So I have x minus 2 squared, and that's going to be over 25. And I have a y plus 4 squared, that's going to be over 20 equals 1. There's my standard form equation for it. Let's actually grab it, and we'll shrink it down, give myself some room. All right, so there's my standard form equation. If I look at the order, I can see right away that this is a horizontal ellipse because the x term comes first. So I can see that a squared is 25. So a is 5. And I can see b squared is 20 on it. My center is hk. So my center is 2, negative 4, based off of what I see here. I have my h and I have my k. And if I take a look at the rest, I want to see my vertices. Well, the horizontal formula for vertices is your vertices is h plus or minus a comma k. So that would be 2 plus or minus, in this case a is 5, comma negative 4. So 2 minus 5 is negative 3, negative 4. 2 plus 5 is 7, negative 4. So I can use my formulas for those. Now the foci are from c squared equals a squared plus b squared. So c squared equals 45. 9 goes in there, so that would simplify into 3 radical 5. So the foci is h plus or minus c comma k. So that would be 2 plus or minus 3 square root of 5 comma k. Now 3 square root of 5, if I look at that, that was going to be, if I look at the decimal, negative 4.7 comma negative 4 and 8.7 comma negative 4. And so we have our focus. So in this case, since I'm not graphing and I can't count, I'm relying solely on using these formulas on this page and using to plug in my numbers on it. I'm not scrolling up and down the entire time because I have them memorized where I could just write them down and use them, but do pay attention to see that's what I'm doing. So though it looks a little bit different, the harder part with completing the square with hyperbolas is that negative. So if I pair them up again, so I'm going to pair my y's together, and I'm going to pair my x's together. I'm going to move this negative 128 to the other side by adding it. So what do I have? I have a y squared plus 12y. That's in perfect form for me to complete the square. I have a negative 4x squared plus 40x. That's not quite in good enough condition yet. And a positive 128 here. So I don't mind the first terms. I don't mind my y terms, because it does not have a coefficient with that y squared. That's not 1. It's perfect for me. I do get annoyed with this because I have a negative in front of that x squared, let alone a negative 4 in front of that x squared. So I need to factor out that negative 4. But when I factor out that negative 4, it's going to affect the first term and make it positive, but it's also going to affect the second term. It's going to make it the opposite. That's going to make it a negative 10x. I'm going to have a placeholder there for that one for when I complete the square. And it's going to equal the 128. And I need my two placeholders to keep the equation balanced. I need that blue one for the y term, and I need that green one for the x term. So now let's complete the square. We are going to take half of that 12, which is 6, and I'm going to square that. That's going to give me 36. Since I didn't factor anything out over here at all, it's still just a y squared. I don't need to be careful. I can just go ahead and put a plus 36 here. But I do need to be careful when I complete the square here for multiple reasons. One, here, it's take half, you get negative 5, you square it. That's going to give me a positive 25. And I have to be cautious because I'm not adding 25. I'm adding negative 4 times 25. So I'm adding negative 100 to it. So that's going to give me a y, looks like plus 6 squared, minus a 4, x looks like minus 5 squared, equals, I have 128 plus 36 minus 100, which would be 64. Again, for our hyperbolas and ellipses, you want them to be equal to 1. So I'm going to divide each term on the other side by 64. And that's going to give me a y plus 6 squared over 64 minus x minus 5 squared. This would be a 16 on the bottom, equals 1. Right away, I can see that this is going to be a vertical hyperbola because your y term is first. So my transverse axis is vertical. My center is the coordinate h comma k, so do be careful. K is negative 6 and h is 5. It's on the opposite order, so the center is 5, negative 6. The asymptotes. We can always remember the y minus k, so that y plus 6 is given to us. The x minus h, the x minus 5 is given to us. Our job is really to look at the formula sheet if you need to and see it's for vertical plus or minus a over b on it. So if I'm doing this one, plus or minus a over b is going to be my slopes. So plus or minus a over b. My job is to find what's a and what's b. So in this case, a squared is 64, so a is 8, so plus or minus 8. B squared is 16, so b is 4. So plus or minus 8 over 4, simplify that, and I get 2. So there is concept 2, which is completing the square to write an equation of a, well, that says ellipse, of a hyperbola, and identifying the important parts. That's concept 2 on your quiz. The part you need to be careful with is right away when you are completing the square is factoring out that negative, which then changes the other operation for it. Concept 3, just like it was for ellipses, is being able to write the equation of, again, this says ellipse, sorry, of a hyperbola when you are given a graph. So if I take a look at this, well, first off, what type of hyperbola is this? And this, well, it's a horizontal. I mean, that's pretty obvious. It's a horizontal hyperbola. So I'm just going to write down that formula. X minus h squared over a squared minus y minus k squared over b squared equals 1. So my job is find h, find k, find a, find b. See how hard that is. Well, looks like h and k is given to me. My center is the coordinate 3, 1. That's not bad. I mean, look at that. I have x minus 3 squared. I don't know what it's over. And I have y minus 1 squared. I don't know what it's over. Equals 1. I mean, technically, I have half the equation right now. That's beautiful. Now, how do I know the rest? Well, this is your vertex right here. And this was your center right here. The distance from your center to your vertex is a unit. So in this case, a is 2 for it. So I have from the center to the vertex is a. That's the definition. So a is 2, so a squared is 4. So a 4 goes here. The question is, how do I find the b value? Because it's not direct. I mean, your focus is visually, you could see it there if I plotted the point. But your b value, if you look at all the examples we dealt with, the b value is found through your asymptotes. And that's kind of why that box is there. It's meant to help you see. You can see your run for the slope. If I think about it, I see my run is a on the bottom is 2. I can figure out what my b value is. So if I look at my rise, I'm going up 1, 2, 3 units. To the right 2, I mean, that's my slope to get that asymptote. And the slope for a horizontal hyperbola is plus or minus b over a. So I can use that box and see that my b value is 3 on it. So based off of this, my b value is 3, so then b squared is 9. So we're going to use for hyperbolas the asymptotes to create our b value, which is why for number 6, number 7, you see I have that box drawn. That box is drawn for you so you can see what your rise and what your run is. And it's your job to look at the formula sheet and see, okay, which part of that rise run is your b value. Sometimes you're not going to be given the graph. Sometimes you'll be given information on it. And in that case, I would sketch a picture. So I have -1, -1, and -1, 7 for my vertices. So here's right there. Here is -1, -1. Again, it doesn't matter about scale. There's one vertex. Boom. -1, 7. Again, doesn't matter scale. There's the other vertex. Boom. And it's my job to write the equation. Well, since my vertices are up and down, I can see this is going to be a vertical hyperbola, which gives me the formula. Y minus k squared over a squared minus x minus h squared over b squared equals 1. That's the formula for a vertical hyperbola. So I need to find hk, ab. So let's start with the center. Always start with hk. Now remember, your center is the midpoint of those vertices. It's going to be the midpoint of the foci as well on it. So I can add the x's plus negatives and minus. So -1 minus 1 divided by 2 and -1 plus 7 divided by 2. Or I can just look at the middle of -1 and 7. So my center is the coordinate -1, 3. So here, right here, again, not to scale, but bam, there's your center. Now, why is that helpful? Is because this is your h and this is your k. So I now know part of it. I now know it's going to be y minus 3 squared, and I know it's going to be x plus 1 squared. Don't know what it's over, but I have half my equation. But do keep in mind, the distance from the center to your vertex is a unit. It's defined by that. So a in this case is 4. So from the center to a vertex is a units, which is 4 in this case. So a squared is 16. Very good, very helpful on that. And then I have, what about my b squared? Well, I'm not told anything about b squared, but I am told my focus. I have a focus at -1, 8, and I have a focus at -1, -2. Well, how is that helpful? Remember, from the center to the focus is c units. So in this case, c is 5. So from the center to a focus is c units, which means c squared is 25. I don't want c squared, I want b squared. Well, we're told that if we have c squared and we have a squared, we can use this Pythagorean theorem to find b squared. So I have 25 equals 16 plus b squared. So b squared is 9. I don't have to solve for b because the formula wants b squared. And so there you are for it. So it's really important you understand what is A visually. It's the distance from center to vertex. What is C visually? It's the distance from center to focus. And if you're given a graph, you're always asked, is it vertical or is it horizontal? And in this case, it's opening up and down, so it's vertical. So I can look at all the formulas for a vertical hyperbola. So that's what I'm doing right now is I'm writing down the formula for a vertical hyperbola. And it's my job to plug in what I can see. Well, I can see my center right away. My center is the coordinate -2, -1. So my h is -2, my k is -1. So that's going to be y plus 1 squared, and that's going to be x plus 2 squared. I don't know what's on the bottom of them, and it equals a 1. So now I need to find what's A and what's B. So if I'm looking at this one, what I want to make sure I do is realize that A is the distance from a center to a vertex. So in this case, A is 2. So from my center to my vertex is A units. So A is 2, so A squared is 4. So that's going to go there. And remember, I'm giving you the box on this one so you can actually see what the slope is. So I'm going up 2, right 2. That's my slope. Now this is your A right here, so that means my run, if I think about the formula, and I were to look at it, the formula for the asymptote slope in this case is going to be plus or minus A over B for a vertical. So in that case, my B value here is 2. So then B squared is 4. They just happen to be the same one, and there is your equation. When you're given a graph like this, I'll give you the box so you can kind of see the slope of what A and what your B is for it. But given this information, you have to figure out what is A, what is C on it, and then use the Pythagorean theorem to go backwards. Now, the way your quiz is set up for this is the same structure as the ellipse quiz. There are 3 main concepts on it, and it's outlined really the same as the notes on it. You are expected to be able to identify all parts of a hyperbola and analyze the graph of it and plot all the points. So you have this formula sheet to help you out with it. You are expected to be able to complete the square to get a hyperbola in standard form and identify certain parts of them. The harder part for the completing the square is that you have to factor out that negative in this case. And that's going to affect the next term when you do that as well. The third concept on your quiz is being able to write the equation of a hyperbola from either a graph or information given in words that could be graphed. But this is the structure for your hyperbolas lessons and your quiz. If you have any questions, please reach out.